I hope my screen is visible. Okay, it is there, right? Yeah. Okay. So, good evening, everyone. And this is the final session of the data engineering series that we have been having since last couple of months. So, we have now tried to, build various components of the complete data engineering pipeline in different sessions, and the concluding session would be on the productionization and deployment of those pipeline and how they are maintained in real time. So the title of the session is production deployment and maintenance of data pipeline. So the things that we will be covering in this session is how do we handle incremental runs of the engineering pipeline, how do we schedule these pipelines through uzi, then how do we monitor these pipelines, how do we monitor multiple instances of these pipeline, and then how do we maintain logs of if the run was successful or not, so maintaining logs for debugging purposes, and then the best practices for data pipeline deployment and health. So, before we actually start with our today's agenda, I'll quickly brush up the things that we have covered so far and what all things we have tried to build in the previous sessions. So, what we did was we tried to connect to two different data sources. One was JSON data source, and the other was normal Excel data source. We tried to do some data cleansing using Python. Then we did some transformations using a tool called Alteryx. Then after the transformations, we try to dump the data in the Hadoop ecosystem. And then we also try to run some queries on the database using Hive. So this is what we have established up till previous session. And if we have any questions regarding how to build a data engineering pipeline, not just based on what we have demonstrated, but if there is anything else, maybe we can have some questions first, if there are any. Okay, we can also have some Q&A session at the after all the content has been presented. So at the end of the session as well, we can have another Q&A session. So yeah. So now let us try to understand how these pipelines are scheduled and maintained in real time. So as you can see, there are a lot of components that are involved in a data engineering pipeline. The main data source, then some cleansing and data transformation tools. Not necessarily always Alteryx is used. Python will also suffice, but whatever it is that you are doing, you need to have that tool in place, and that should be scheduled on a regular basis to make sure that the data is getting fetched as per requirement. Then the data has to be dumped into our Hadoop ecosystem. So these are three different components that come in picture, and we have to automate this entire pipeline for a regular run. And if there is at all any issue or some failure occurring at the pipeline, then how do we debug it, and how do we try to try to maintain the overall health of the pipeline. So let us look into it into detail, so how exactly that happens at industry level. So the first thing that we'll be covering is handling incremental runs of the data pipeline. So basically, let us say we have created this complete data pipeline. I'm trying to get some stocks data from this API, and then I'm dumping it into my Hadoop ecosystem. So every day I need to have the latest data set, which would be of yesterday. Let us assume, for example. So every day I need to have a new data, small or incremental data dump, as we term it in in industry level. So it's an incremental data dump. So every day I need to have the previous day's data. So how do we actually deal with this incremental runs of data pipeline? So these are a couple of pointers on that. So first we have to decide on a user accepted frequency. So the current example that we are working on is of stock markets. So for stock markets, we need a daily, run, and we need to have the previous day's data set into a database basically. But then there are certain kinds of databases, which not necessarily require a daily run. So we need to first understand the business importance of the data set and how frequently we want the latest dump of the data into our ecosystem. So the most commonly, used frequencies are the daily refresh, the weekly refreshes, and the monthly refreshes. There are also some of the databases which require hourly or minute basis refresh. So based on what is the business importance of the data set that you are trying to ingest through your data in engineering pipeline, that will decide the frequency of the data set. So if I have to give you an example, the stock market data could also be refreshed on the minute basis or hourly basis based on whatever use case that you're working on and whatever is the business requirement. So that can be either monthly, hourly, or even daily. For say like you can deal with yesterday's data as latest data, then even the daily refresh would work. Then let us say if you want to kind of gather all the news related to a particular company in couple of days or in recent days, then that can be termed as a weekly refresh. So weekly you are collecting all the news that has been published based on the company that you are studying, and also that data can be kind of refreshed on weekly basis. And an example of monthly refresh would be, let us say if there are any organizational changes happening in company. So these things do not happen these that frequently that we need to have the data refreshed on daily or weekly basis. So such kind of data sets can be identified as monthly refresh data sets. So based on kind of what is the business importance of the data, we identify these frequencies, and then we have to set these frequencies and as parameters into a file when we are scheduling this pipeline. Then setting the data and time range and parameters in the code. So this goes in hand with the previous one. So let us say I want to have it as a daily refresh. So I'll have to give the parameter as I want it as current date minus one. So I want data up to yesterday, let us say. Or let us say I want it on weekly basis, and then if I want it on minute basis, then I'll have to schedule current time minus one. So whatever these parameters are, we have to set it in the code, and the code will read it, and based on the conditions and the parameters I have given, it will fetch the latest dump and dump it in the data lake as of now. Then parameterizing all variables in the code, such as engine, user, and etc. So basically, when we are trying to connect to any of the data source, there is certain authentication mechanism that comes in picture, and there are certain drivers that are associated. So let us say if we are trying to connect to any RDBMS source, you will need a JDBC or an ODBC driver. So that is a kind of engine. Then you'll have some username and password to connect to the data source. So all of these you cannot give it or pass as by default strings to the code. So you will have to pass parameters at each and every place, and then the code the your central engine should be able to match up those parameters, connect to the database, and then fetch the data based on the frequency that you have mentioned. So that is why you have to parameterize a lot of other parameters as well. Then all of these data is stored in a configuration file. So configuration file will have the frequency, the date time range, the username, let us say the passwords, then what table you want to dump the data into your Hadoop ecosystem, a lot of other things. These are just to name a few. So a config file will have a hold of all of these variables, and your central engine will try to read this config file, and based on that it will then dynamically create the job and then fetch the data from the data source. Then you also need to deploy the production tables DDL beforehand. So let us say you're trying to dump the data in an XYZ table. So the XYZ table should already be created in your Hive metastore using the DDL language. So we have already seen how to create a DDL for a given table. So that should already be in place before you run and execute the entire job. Then analyze and ensure the platform has enough resources. So let us say you have to run 100 jobs on daily basis. So we need to make sure that, if we have enough resources available to carry out those 100 jobs, how do we want to schedule those jobs? Do we want to run them parallelly or serially? So based on that, we need to have enough resources. Basically, we need to have enough RAM, because these are all, heavy lifting jobs, because the data that gets fetched and that gets dumped, it can be in GBs as well. So the resources that we have should be enough to take care of such huge data dumps. Then set up processes to archive outdated logs and files. So basically, when a job is successful or it is failed, it is always getting logged into a logger file. So once and there is also a particular threshold time and date for which the log files are maintained. So let us say the most like we can have the log files for the latest 1 month of fetch or like data ingestion pipeline. So we do not need what has happened with the pipeline for before last 6 months, right? So we need to have an automated mechanism which will dump or kind of erase the data for the last 6 months, and then keep current, let us say 1 or 2 months, based on what the requirement is. How recent logs do you want for analysis purpose? So we need to have a process in place to get rid of those outdated log and files. So this is what the big picture looks like. So as you see at the central is the configuration file. So it basically connects to the authentication vault. So there are very enterprise level vaults are available, which actually store your username and password in an encrypted manner. And there are also, if there is a need to connect to drivers, there is also a different drivers directory. So the configuration file will read from this authentication vault in the drivers directory, and then it will connect to whatever data source it has been asked to connect to. And then it will connect to the data source, it will fetch the data, and then it will, after doing some cleansing and all of that stuff, it will dump the data in the Hadoop ecosystem. But if you see, all these actions get monitored by a logger file or logger mechanism, as you can say. So if there is any sort of failure at any sort of step, so the logger file creates a log entry immediately, and there is an alert mechanism. So there are different ways through which this alert is raised. For in some cases that has been raised in your email, that this particular job has failed. So basically, if there is a failure of one job, that should not affect the remaining jobs that are in queue. So we have to handle also have to do exception handling in this case. So if one job is failed, it bypasses that job and then it moves on to the next job, and it should not fail the entire mechanism. So that is why the alert gets raised in the mailbox that this particular job has failed. However, the rest of the jobs are running and the logs are maintained for that particular day or instance, per se. So that is the big picture of how the entire productionization of the data pipeline looks like. Before we move on to the next segment, do we have any questions? Okay. So now to explain how scheduling happens of these data pipelines through Huzi, I would like to hand it over to Pratiksha.
Thank you, Surbi. So now we just heard about how we. Am I audible? Okay.
Yes, you are.
Okay. So we just learned about how we productionalize the pipelines. So a very important component of productionalizing is to scheduling a pipeline, which is basically enabling it to run at your decided frequency, whatever it is. It could be daily, hourly, even every minute. It could also be a streaming application where the pipeline runs continuously, as in when the messages are received, they are ingested into the pipeline. So, scheduling is basically running this pipeline at this decided frequency. So, since we've seen, we've mostly gone through Apache related technologies and frameworks. We have tried to incorporate Apache Uzi into this session because Uzi is a framework or it is a service that will enable us to do the scheduling of different MapReduce or Hadoop jobs. Uh, should we?
Yeah, just a minute. I'm just sharing. There was some issue.
Okay, okay. Okay, so once the
Visible?
yeah, it is visible now. Okay. So Uzi is a service that is hosted on a cluster or a server, and we or our applications, data engineering applications as clients, we go and call that server. Basically, the big box that we see in the middle is the Uzi server, and it has all the it has components like bundles, coordinators, workflows, etc. So first we'll look at the workflow. So a workflow is a set of actions. Basically, now if we pertain to our example where of our stock API example, so the complete process, the end-to-end pipeline are our different actions, is a set of actions that will eventually grab the data from API and eventually load it into our target data set. So this entire set of actions is a workflow. So we will have all these actions defined in our workflow, and then there's a coordinator which will, depending on your time or your frequency, it will keep on calling this workflow, calling or starting this workflow. So we'll look at workflow again in detail, how it looks like. But basically, your pipeline is your workflow, and this workflow is called every time. Let's say your frequency is daily, so it will be called daily at the particular time by the coordinator. And on the top of that abstraction is the bundle is nothing but a collection of coordinators. So let's say there is one product and it has two three components to it, or two three important workflows to it, and every workflow is scheduled by a single coordinator. Then the group of these coordinators will bundle them together so that we can maybe restart or redeploy them together as an entire product. So that is what bundles are for. But we can also schedule coordinators without bundles. We can schedule a single coordinator which will take care of a workflow, and this workflow is nothing but a set of actions that will basically execute your pipeline steps. Okay, so now we saw that the coordinator basically triggers the workflows. So there are two ways through which we can trigger Uzi coordinators. One is time-based dependency, which is you can just say every day, like we will provide the frequency that is daily, and we'll provide the time. Let's say 2 o'clock in the morning. So every day 2 o'clock in the morning, the coordinator will trigger your workflow. And the second kind of dependency is file based dependency. So let's say there is some other coordinator. On success of that coordinator, it will create a file, and once you see that file present in your HDFS, then you trigger this workflow. So this coordinator will keep on looking for that input file. If it is present in the HDFS, as in when it gets that presence of the file, it detects the presence of the file, it will trigger your workflow. So these are two kinds of dependencies: file-based dependency and time-based dependencies for OC coordinators that are generally used in data pipeline architectures. So on the left side of the box, what we see is web-based applications, or Uzi is basically a cluster which can be accessed through APIs. So what we generally do is we log into our hosts, our edge nodes basically, and from there we log into the UZI command line interface, the CLI, and through command line commands, we try to communicate with UZI. So let's say I have submitted a job. We can submit a job through UZI command line interface, or there's also a UI through which you can monitor your UZI jobs. So through these commands, we can see the information of the job. We can suspend it from running. We can kill a job if something is going wrong. We can restart a job. So all these kinds of operations can be performed on your UZI workflows, coordinators, or bundles. Or even at the action level inside a workflow, there are actions or different steps. So those also we can manipulate using the UZI command line interface. So the left side of the box is showing us how do we communicate with this UZI server. At the bottom box, the database box that we see is bundle, coordinator, and workflow. So when I say that we set the frequency, we set the timing for the coordinator. So all of that is defined in a config file for that coordinator. So all those configuration files are present in some special HDFS directory. So the yellow, light yellow box denotes that HDFS directory where the bundle or the workflow configuration files are placed. The configuration files have the details of what steps needs to be performed, when they need to be performed, what are the dependency files, what output needs to be done when there is successful completion, etc. So all those configuration files are present there. And on the right hand bottom, we have our HDFS or our Hadoop cluster in which there are all our data scripts is lying, and depending on that, operations will be performed. So our workflow action, now let's assume our workflow action is to run a Hive query. So that job will be submitted to the MapReduce framework on our Hadoop cluster, and using the files and data present in HDFS, it will be processed and written accordingly. So in this way, the UZI server communicates with the Hadoop cluster. So this is on a high level how UZI schedules our workflows and pipelines. Okay, so this when I talked about workflow, this is a zoom into a single workflow. Now let's go through what I mean by actions and what I mean by various status of the workflow. So in a workflow, this, if you see, this is basically a set of actions. The blue boxes that we see: sub workflow, run report, delete trigger file, notify via email. So all these are specific UZI actions. Now once, let's say there's a trigger file that the coordinator is dependent on, it reads that trigger file and it is passed on to this workflow. This workflow will start. Then we have some decision nodes also to enable conditional path selection in UZI. Like you can put a node which will check for some particular dependency file or some particular condition, and on its failure or success, it will decide if the workflow needs to process or not. So this decision node, let's say it says yes, it passes, and then it will go to a fork. So what a fork does is, now I have two, let's say I have two actions, sub workflow and run report, and both of them can run parallelly. So the fork node says that run both of these actions parallelly, and if you don't have the fork node, then the actions will be performed sequentially. So right now I have fork, so my sub workflow and run report, both these actions will start running parallelly. And and on, if any of these fails, it will transition to notify via email action. So I will also define this notify via email. This, the email action is a specific kind of action that UZI gives us, and if you provide it with email address or the distribution list that needs to be notified when any of the action fails, we can process it likewise. Like you'll get alerted in case any of the action fails. So let's say without any error, both of these got completed. Then there is a join node in your Uzi workflow config, which will take this, which will wherein it will wait for both of these actions to finish. And once both of these actions finish and the uh, join node condition is basically completed, after that, whatever next in sequence actions are there, they will get triggered. So after this, there is a delete trigger file, which is an HDFS action. So these are just example actions basically to give us insight into what kind of different actions can Uzi perform. Hive actions, Java actions, HDFS actions, HDFS, by HDFS actions, I mean HDFS delete, HDFS copy, HDFS move, those kinds of actions, and email action. Apart from this, we can also run shell scripts, pig scripts, and all kind of Hadoop related frameworks are there. Uzi enables us to run those kinds of scripts through these actions. And on successful finish, the workflow will end successfully. Otherwise, if there is any kind of error, we'll get a email notification. We'll have to code it. We have to write the config file in such a way that on any error, uh, our workflow transitions to this email action, and after the email action, we kill the workflow after the failure. So this is a zoom in. This was a zoom in into the how a particular workflow looks. And inside these blue box, which are our actions, we have our code written, basically what Hive script we want to run, what Java action we want to run, what Python we want to run. So if you want to run a Python file through this, we will enable a shell script action, and through that shell script action, we will give the Python bash command to run that Python file. So this is how a workflow looks like. Do we have any questions on this up until now? Okay, so this is a workflow which a coordinator will trigger based on its time dependency or file dependency, and this is how we ensure timely run. Okay, we'll go to the next slide. Okay, so we have a question. Do these decision nodes actually exist as actions in Uzi? The decision nodes, I don't think they're actions, because actions are so in the config, I've never coded in, or I have never written any config for decision nodes. I generally have written forking and joining I've done, but I would assume just like we fork actions, we can write conditional nodes in Uzi directly. I think the configuration will be readily available for that in Uzi documentation, but that is a nice question. I will find out the config and I'll pass on through the volunteers in the group somewhere about how to write the decision notes. Okay. Uh, Monitoring instances of the pipeline. So now let's say we parameterized our code. It is ready to handle incremental or partial runs, and we have scheduled our pipeline. Now to maintain and monitor that pipeline is also a data engineer's primary job. So we have to take care that the pipeline is running as expected and it is providing reliable data that the data analysts can trust on. So we will just go through what are everyday checks that we do as data engineers to ensure the health of our pipeline is all right. So The first thing is we monitor the schedule of the pipeline. Monitoring the schedule of the pipeline is basically checking whether it is running at expected time or not. uh, we check if like now there's a concept called as nominal time or schedule time. Let's say it is 2 o'clock in the morning and my report runs 3 hours, and by 6 o'clock I need it ready for my analyst to start viewing the report. So I have scheduled it to run at 2 o'clock in the morning. So every day I will keep alerts, or I'll somehow have visibility into that start time of my pipeline. If it starts late, I should get a visibility and I should be able to calculate how long will it run. If it is started late, how long will it run, so that I still will be able to deliver my data set within the SLA. SLA SLA is nothing but service level agreement that we have with our end users. Now, in our example, I have my SLA at 6 a.m. and if my pipeline starts 1 hour late, I will still be able to complete it within SLA. But if it is around, if it is 2 hours late or something like that, then it is my responsibility to proactively communicate to the end user uh, that the data set load will complete this much time late, according to how much ever late it is. um, so that is monitoring the schedule of your pipeline. If it is long running, if it is stuck, if it is starting late, if it is ending late, if it is not started at all, and communicating to your stakeholders likewise is the primary check that we keep on doing. Okay, so we have a question. If it is not scheduled time by, then won't it be due to crunches? Yeah, so sometimes due to resource crunch or any other issues, your coordinator would not start at the scheduled time, or your coordinator would start and trigger the workflow, but it might get stuck in between. So you have to develop processes or dashboard on top of your Uzi status or Uzi information, or otherwise your job should keep on logging or writing logs to what is happening with its steps, so you can figure out where exactly it is getting stuck. You can with some manual intervention or through some automated processing, it should take care and proceed on completion. So we'll go to the system resource crunch that happens generally. That is a lot of times the reason for late running jobs. We will come to that. And each action of the workflow not dump run status anywhere, I mean in DB or publish message. Yes, so the question is, can we keep on logging the status of actions to some DB? So yeah, so what we do in our organization is we have a dashboard in place which is built on top of Grafana, and it is InfluxDB at its as its database. And my data pipeline action will keep writing its status to that, and on top of that influx db where I'm writing the status, my dashboard will show its status basically. So likewise, depending on what resources you have and what expertise you have, you can build monitoring dashboards on top of your pipelines. But you have to ensure that you're monitoring this status of your actions or your pipelines regularly whenever it is expected to run. Okay, after that, internal and external dependencies. So like I mentioned, apart from the uh, time dependency, there could also be file dependencies, which could be external or internal. Maybe your another coordinator is writing files that is taken by the coordinator as an input, or maybe there are upstream dependencies, or there are partners that give you files, and then on reception of those files you start your workflows. So you have to take care of that internal and external dependencies. In case any of those dependencies is late, then your workflow eventually starts late, and that could also be a reason in your SLA getting missed, or your data set loading late than expected. So in such cases also, you have to go and communicate with your upstream partners, or check your previous coordinator why the dependency files are not received, and take actions accordingly. Okay. Then there are basic success and failure checks. It's basically a simple check that you can keep logging every day if if your workflow was a success or a failure, or if there was a failure and then you reran the workflow and then it went fine due to some reason, or you did some debugging and then it went fine. Just we can just keep a check to keep on monitoring the health of the pipeline. After that, primary count checks and business specific uh, metrics are basically, what should I say, data quality checks, or those are the those are the checks where the level of your quality checks goes right into what is getting loaded into your data set. So a simple count check could be a source and destination, or source or sink comparison, like how many messages you are receiving from source and how much you are writing into destination. So if there is no explosion inside your pipeline, or if there is no, multiplying of your records, then ideally your source and destination count should match. Or source, destination, if you're not doing any aggregations, um, your source count should always be lesser than your destination count. So depending on your use case, you can put in count checks. Or there could also be attribute level count checks, like, let's say for a particular attribute you would expect 100 records. For a particular kind of attributes you would expect 1,000 records. So there's a 1 by 10 ratio that you would expect for one attribute and the other attribute. So those kinds of checks that go into the level of your data quality should be placed. And business use case specific metrics are similar things, like after every step, after every transformation, how many records are expected, how much it is expected to blow up, what should be the volume of data. All those checks you could keep logging and build dashboards on top of it, and place alerts. So if there's anything wrong, or if any data from any particular attribute is missing, you should be alerted likewise. After that, analyze the schedule metrics of the pipeline history. So like I said, let's say you're every day you're keeping a record of if your pipeline was a failure or a success, how many times it failed, why it failed, after how many reruns it was successful, if it was down for some time, why it was down, and all of that. You could analyze this metadata also and figure out where there are bottlenecks in your pipeline, why it is getting stuck at a particular time, and you can apply optimizations so that you can improve the consistency of your pipeline, and ensure your data is trustworthy. Error rate of the pipeline is nothing but the number of times your pipeline failed than expected successful runs. And all this analysis we do to identify bottlenecks and optimize our processes. And eventually, resource check, like we had a question earlier, if there are resource crunch. So we make it a point that there is some decided frequency, and on that particular time we go and check, uh, do is there enough resource available for my workflow to run successfully. So it could be file resources, it could be system resources, it could be CPU, it could be the queue space that my workflow gets. So all this all these metrics also can be published from the resource allocator or your resource negotiator to figure out uh, if there is resource related bottleneck. And like Surbi had mentioned, we it is there should be automated processes in place to delete any old files that get generated by our workflows. Otherwise, these log and dump files uh, get created and they are outdated and they keep occupying the space, and then your normal runs do not get enough space or queue to run, and that is why your resources are they are consumed in inefficiently, and it could result to delays in your workflow. So it is better that we have automated scripts that take care of deleting and removing these old or unused unwanted log files. Or also, let's say you have upstream dependencies where there are source files that you eventually transform and load it into your data set. So once they're loaded into data set and we've ensured that the data quality is as expected, after that whatever files you received as input, those won't be needed unless there is some very rare scenario where your systems go down or your tables are flushed out or something like that. So in that case, what you can do is you can zip them, or you can uh, compress them somehow and put them into some archive directory or archive folder, so that your regular space is available for data sets to process. So those processes should be automated in your pipelines as well. Okay, so we have some questions. Can there be cross dependencies between two different workflows managed by two different coordinators? Yes, we can set dependencies. So Uzi provides us with the ability to create files as an output of particular action or particular workflow. So um, so output of one action can be the input dependency for second action, and this is how you can establish cross dependency. And second question is, do we generally build recovery actions for failed action into pipeline itself? um, Recovery actions, so depends on how frequent the failure is, or again depends on your use case. If you could automate the recovery, it is great. Like if there's no manual intervention required and somehow you can figure out what needs to run in case it fails, then you can absolutely incorporate that recovery action into your workflow, which will get triggered only if there's failure. So instead of directly on failure, instead of directly transferring your control of your workflow to the email action, the failure email action, we could transfer it to that recovery action. And even if that fails, then we could transfer it to the email failure action. So if that is possible, that is a great solution to have. But if there's no specific recovery, then we need to generally go and check what exactly went wrong and what needs to be fixed or what needs to be added to complete. And if sometimes there are queue obstructions or something like that, in that case just a simple rerun also works. So we can also put uh, like if a workflow fails, there are number of retries that we can configure for your Uzi workflow. So we can say retry for 3 times before actually failing the workflow. So if the workflow fails for one time, it will retry it, it will retrigger it on its own. The second time it will again, depending on the number of retries, it will retry and then it will eventually fail. So that is also possible. Do we have any other questions? Okay. So maintaining data pipeline logs. This is just a complementary action to whatever we discussed so far. It is uh, we maintain logs, like let's say we saw a failure alert in your mailbox. So the first thing you'll go and check is the status of the actions of your workflow. At what action did your workflow fail? And then you'll go and to able to figure out what exactly went wrong, we need to enable logging into our systems. We have to make sure that we write logs of the process that is happening. Uh, the the first and foremost primary reason for that is to be able to debug any failures, or if any, or to figure out what went wrong, and to figure out what to fix to enable or re-enable the pipeline to continue processing is the main reason why we write logs. After that, what I've tried to write is, yeah, so logs can come through different layer of the pipelines. Like even if a hive write is a hive, so you have an action that basically writes into a hive table. So for that you could have map reduce jobs, the map reduce engine jobs. Then you could also have logs from your yarn, that is your resource negotiator, which is providing resources for this writing job to happen. So there are different levels of logs, and you have to you have to build expertise in to be able to read all these different kinds of logs to sometimes figure out what exactly went wrong. So to keep an eye on all the different kinds of layers that are able to write logs, or wherever your processing could go wrong. Apart from this, there is also business level logs that you need to write. So through your pipeline, there should be data quality checks that are logged, like what is written, what is, how many messages are read, how many messages are written, how many are processed, how many are dropped, how many duplicates were there. All these kinds of business related rules should also be written or logged somewhere, so that we can accumulate these logs. We can do some analysis on this historical logs, and then we can figure out optimizations to the process, and basically making the pipeline more strong and more trustworthy. Logs can be very helpful. Next slide, Surbi. So the crux of the entire session, we've tried to bring it in this last slide, where we've written the best practices for pipeline deployment and health monitoring. Um, I'll just read through them one by one, and I'll again reiterate through whatever Surbi and I talked about. So it is a kind of summary. So apply modular design principle to data pipelines is basically, modular design principle is nothing but the basic design principles that we have for our normal software projects, that the pipeline should be scalable, it should be there should be proper visibility to different steps of your pipelines. Then if if there is like more data, it should be able to handle that as well. So So the architecture basically should be in a such a way that your pipeline is maintainable, scalable, and operationable properly. Second is validate the accuracy of data throughout the pipeline. So like we discussed, the data quality of what is getting written should also be a very important component of your pipeline monitoring. We should be able to detect if there is any corrupted data, if there is any incomplete or incorrect data that is coming from source. Also sometimes there are some key attributes which are missing. So let's say in the stock data, if you don't have the open and close prices, then that data is basically useless for us. So we should deploy checks on these critical attributes. So I should have a check saying that if I get an empty string as open price or close price, then that should be marked as an incorrect record or invalid record, and I should be notified that such incorrect messages are coming in. And on reception of these alerts, I will go and talk to the source team that I'm getting null values or I'm getting empty values for open or close price, and that is very critical data for my analyst. And we should take some action immediately to enable that critical data again back into the data sets. So these kind of scenarios should also be uh, should be alerted. The engineer should be notified. We have to place such checks so that we are notified of these issues and we can take action on them. Establish a testing process to validate changes. So our pipeline should have multiple test cases written, which covers the critical operations of the pipeline. So the test cases. So what happens is, if there is any change, let's say an attribute was renamed from close price, an attribute was renamed to closing price. So now I will have to change all occurrences of closing price in my pipeline. So let's say I majority of them I renamed. There was one or two which were remaining. So in that case, when I run my pipeline in my test environment, my test cases will catch these mistakes, and I'll get to know where it is exactly failing, so I can correct it there itself instead of this failing into production and creating incorrect or incomplete data. Uh, it is always it is always a good to have testing environment where test cases are written that covers majority of your critical code, where any changes can impact the processing of your pipeline. After that, engineer data pipeline for varying operational requirements. Um, so by this, so basically, your data pipeline should be able to handle any amount of load. They should be stress tested before they are deployed. So now let's say if you so now I work for a retail organization, and for my organization during Christmas or during Thanksgiving, there is a lot of data. There is double the load that my data pipelines have to handle. So in that case, we should stress test the pipelines first in production environment to ensure that uh, if there's more data or more volume, uh, it is not getting affected negatively. Then parallelized data flows. It is always a good idea to identify components that can run parallelly in your flow and parallelizing them, so you can save time and resources together for your data sets to get loaded. After that, implementing documentation. So another basic software principle that software development principle is to have documentation in place, so that if there's a new team member onboarding or if there's any issues, it is always nice to have that diagrammatical flow in front of your eyes, so that you can pinpoint where exactly it is getting wrong, and then you can deep dive into that. So having proper documentation always helps. It is a great tool to have for debugging also, onboarding also, and creating new data sets or optimizing your existing architecture. And it can provide great insights for a lot of architectural requirements. Then we have used streaming instead of batching. So streaming is, like I said, it is a continuously running application which continuously ingests messages. and batching is scheduled, like daily or weekly or monthly or let's say hourly also. So having streaming is of course more advantageous because you'll have more recent data, uh, you will have more visibility, you will have less chances of failures. So so if your use case and your resources permit, it is always better to have streaming applications instead of batching applications in today's day and age where there's a huge amount of data that is getting created. So also there is no load on your batches, just in case. And the last point is to establish data ownership and data contracts. Is basically the business ownership of data and the physical ownership of the data. Engineers generally have the physical ownership of the data. They're responsible for the data availability there, and business ownership is basically what the business users will take, because it could be some critical data, and it needs to be guarded according to various principles and guidelines for enterprise architectures that organizations have, that we have talked about in earlier sessions. So it is important before we deploy any production data and it is visible to users, we establish this data ownership and we establish this data contracts, so the data is guarded and always used as expected. Data contracts are also established with source team, which with whom we might have input dependencies. Let's say if I have scheduled my flow to run at 2 a.m., then I will have a contract with my upstream partner or my source partner that I should get your file at least by 1:30 a.m. or whatever time it is required to process that file. So I should have it at least by 1:30 a.m. so that my flow can start by 2 a.m. so that I have that 30-minute window to process your file. So that contract needs to be in place so that if it is late, we have something to fall back on, or we have some accountability of the delay in loading of our data set. So yeah, I think that is all. These are some insights into how we productionalize pipelines, how we schedule them, how we monitor them and maintain them, and what should be the guidelines around using these data sets that are created by these data pipelines. So, do we have any questions? If not, I think we can wrap up. Surbi, do you have any comments?
No, I think we have covered it all.
Sure, Tejasri. Yes,
You can also share our email addresses, Tejashri, on the website. So, in case if anyone has any questions, if not now, but after watching the sessions, they can get back to us on our email. Yeah.
okay. Thank you, everybody, for the
Thank you so
patient
much.
listening.